So what we're going to look at today is we're going to look at limits. We're going to talk about what a limit is mathematically, specifically in calculus. This is a unit that will last maybe 2 weeks, and then we're going to move on to derivatives. Okay, so when we're talking about a limit, we can find a limit numerically or graphically, and then we're going to justify when a limit may not exist, because you don't always have a limit. Okay, and we talked a little bit yesterday about maybe the concept of a limit, or today, and what a limit was. So, moving on, what is the goal of this race car driver? Well, he wants to get to the finish line, right? He specifically wants to cross the finish line. So that's what it is. So, what's our limit as to where we will win the race? Well, it's when we're right at the finish line, correct? All right, so we could say here our limit is the finish line. What factors could affect him getting there? Other drivers. What's going on with his car? Did something happen? Did he run out of gas? How fast is he pushing the pedal? And I'm sure a lot of you guys can list a whole lot more than I can come up with. Okay, when finding a limit, you're finding what the function is approaching. Okay, that is very, very, very specific and very important. We don't care what the value is. What is it getting really, really, really close to? So, thinking of the idea instead of what is the value at 3, I'm going to look at what is the value at 2.99999 and 3.00001. What is it getting close to? So that approaching part is very important. We can do this 3 different ways, and be sure you write these down. We can create a table. We can draw a graph, or we can use algebra. We can use 3 different ways. Algebra or analytically we'll probably get to later. Okay. All right. Now, mathematically, this is what your symbols look like. That is how we write the limit. That is the limit of f of x as x approaches c is L. Now, what we are looking at is we are given an x value we are approaching, so we want to know what y value we are approaching. Okay. You're given. So the x approaches c is the x value you are approaching and then we want to find the y value. Y value, or in this case, y to y'all is now f of x. So the f of x value approaching. Okay, so if I look here, let's look at it graphically. All right, so from negative at negative 1.1, what is this value? Okay, negative 0.322. Negative 0.01, what is it? Negative 0.332. Negative 0.0001, so getting really, really close to 1, negative 1 from the left side. So we're coming at it from the left side and coming at it from the right. From the left side and coming at it from the right side. So, at negative 0.09, what's my value? Negative 0.344. What's my value at negative 0.99? Negative 0.344. What's my value at negative 0.999? So negative 0.333. So if you notice the value from the left and the value coming from the right, or the value coming from the negative side of negative 1, and the value coming from the positive side of negative 1 is negative 0.333. Let's see if we got it right. Yep, we did. So it is negative 0.333 is your limit. Okay, so here, find the limit for the following functions. So the first thing I want to do, okay, now this limit right here, the limit as x approaches 0 of sine x over x, it is very, very, very important that you memorize this one. Get it memorized. So first thing I'm going to do is we're going to look at the graph. Now, what x value are we approaching here? It's the limit as x approaches 0. So I'm going to look at the graph, and I'm going to go, okay, as x approaches 0, well, first off, if I go back and I look at that equation, the equation I'm looking at is sine x over x. Why can't I have 0 there? Why isn't 0 a choice? Well, let's plug it in and try. If I have sine of 0 over 0, well, that's bad to begin with because I can't divide anything by 0. If you notice, and if you zoom in really far on this graph, and we will probably do this in class, there's actually a hole that's not shown here because it is so minuscule that it's not at 1.000001, there's a value. And at negative 0.000001, there's still a value. But at 1, there is not. So I call this graph Cyclops. But going back to what the limit is, okay, as I am approaching x from the left, so coming from the left, what y value am I approaching as I am going towards 0? What x value am I approaching? Or what y value am I still approaching? Coming from the left and coming from the right. What is that? It is, yeah, y'all guessed it. It is 1. Okay? It is 1. So now, if we look here at this other graph, we are still doing as x approaches 0. Let's go ahead and view the graph. All right, again, as x approaches 0 here, what does this look like? My y value, more than likely, if I go back to my equation, all right, what is my equation back here? All right, it's, again, why can't I have a limit here? We just talked about it. Well, 0 would end up being on bottom. I would have the square root of 3. All right, I'm just plugging in 0. So 0 plus 3 minus the square root of 3 over 0. I can't divide by 0. I actually end up with 0 over 0. So we have to look at the graph. So looking at the graph, coming from the left, am I approaching a value? More than likely, again, I still have a hole right there that's not being shown. And then coming from the right, am I approaching the same thing? Well, yes. So what do I have? 0.2, probably 0.27 something, 0.26 something, some sort of a decimal. But whatever that value is right there, whatever that y value is my limit. And it is 0.2887 is my limit. Okay, does everything have a limit? Let's look at this. Okay, so when will the pendulum swing stop? When will it actually stop? If I set those balls in motion, does it ever stop? No. So what if I have a graph that looks like that? Do you think I'd have a limit there? I don't know. Let's find out. Okay, limits can fail to exist in 3 situations. if the right side does not match the left side. That's your biggie. You have unbounded behavior like infinities, dealing with, rational functions, or oscillating behavior, kind of like the pendulum I just showed you. Okay? So here, look here. I have two girls right here. They are both walking towards Mission Road. Okay, one's going that way. One's going this way they are walking on Mission Road towards Broadway. You know how we have that in Lubbock sometimes? 57th at Indiana might end here, and then it picks up way there, way further across Indiana. This is the same kind of thing. There would not be a limit here. Although your two girls are both walking on Mission towards Broadway, they're not approaching the same spot on the street. Therefore, much like if I have a graph that looks like that, there is no limit at that x value. Okay? So here, if I look at this value, if I ask for the limit as this particular f of x, as x approaches 0, okay, I have that graph, right? So coming from the left and coming from the right, at 0, when x is 0, do they match up? No. So the limit does not exist. Because the function does not approach the same value on both sides from the left and the right, the limit does not exist. And the way I specifically write that is I write d/e. The limit does not exist. There is no limit. Okay. Now here. Alright. Well, from the left, it's approaching infinity. From the right, it's approaching infinity. But let's talk about that. Is infinity any really specific value? Infinity is just infinity. That side of infinity could be 1,000,000. That side of infinity could be 10,000,000. So would they be approaching the same thing? No. So in this case, the limit does not exist. As x approaches 0, f of x increases without a bound. It will continue to increase and will not approach a real number L. So even though they are both approaching infinity, okay, they are both going in the same direction, the limit does not exist simply because they're both approaching infinity. Okay? An infinity is not an actual value. Okay, last one. Here, if we look at this, let's look at this. All right, I've got sine of 1 over x. Well, this again is one of those oscillating behaviors like I was talking about. Okay, as x approaches 0. All right, well, I've got 2 over pi, it's 1. At 2 over pi, it is 1. At 2 over 3 pi, it is negative 1, and I'm getting closer and closer to 0 here. Okay, 2 over 5 pi, it's 1. 2 over 7 pi, it's negative 1. 2 over 9 pi, it's 1. 2 over 11 pi, it's 1. So since it's bouncing back and forth, okay, the limit does not exist.